Hi, this is Myung Sim, and this is project number 2 for CSE564 Data Visualization. And I'd like to give data video documentation for this project. So for task number 1, it is to do data clustering and decimation. And the first program that I wrote is randomsampling.py, and it generates 5 random rows drawn from CSV file with 1851 rows of data. And this data is randomly drawn, so sometimes it gives fair interpretation of the model. However, it can vary greatly, and it can give greater variance in the data. So the next sampling method used is stratified sampling. So before I go on to stratified sampling, I used a program by writing this program called knee of a curve, and this generates a plot and showing this graph. And as you can see, the elbow point is k equals 3. And also, these are the values generated for k values. And k equal to 3 is seen to be the optimal value. So by writing a program strat sample k means, I drew stratified samples from the CSV. So using k equal to 3, it divides into 3 groups, and according to the size of the samples for each k groups, it draws a certain number of items. And k equal to 0 has the most number of samples, and the next biggest one is k equal to 3. So it clearly shows how the data skews within the model. And for task number 2, intrinsic dimensionality of data using PCA. So var explain.py generates these numbers. First is eigenvalues for scree plot, which will be used for later, and sum of squared loadings in increasing order. By looking at the top eigenvalues, you can tell there are 9 different dimensions. One is used as key dimension, and other 9 dimensions are compared. And by looking at the top ones, these are ordered in order, so you can tell which one to keep and which one to take out. So these are the processes done for dimension reduction. And the another one is to produce scree plot visualization for the data set that has been reduced. So by using decimated data and stratified sampling, and by using backend Python program, this generates D3 data to be consumed by D3.js client. So this is scree plot, and it shows k equal to 3, k equal to 2 value to be the top PCA values. And to see how sampling introduces some bias, I'm gonna go back to the web and see how it changes. So when you switch, so I just had to look at my backend program there. So you're able to easily switch between different sets of data. One is for whole data, and the other is stratified sampling. And the changes are very small, but I think that's the nature of my data set. but it can be much greater if data was very different. And I'm going to look at the top 3 attributes with highest PCA loadings, and these were done by calculating sum of squared loadings for increasing by sum of squared loadings and ordering them in increasing order. So that means the bottom 3 would be the loadings with the highest loadings. So earlier I calculated and found which dimensions belong to the top 3. So for the statistics, in this case would be for Massachusetts high schools in 2017, and the top 3 attributes for total enrollment of Massachusetts high school would be per English learner, and per high needs, and per first language not English. So you can kind of understand what affects the enrollment in Massachusetts high schools. So especially it makes sense to have high needs students as one of the factors affecting the enrollment in Massachusetts high schools. And lastly, for task 3, visualization was done using dimension reduced data, and the visualization was done for data projected into the top 2 PCA vectors with 2D scatter plots. So the top 2 scatter plot is drawn right here, and so one axis is PCA1, the other axis is PCA2, and all the vectors are visualized using scatter plot. Again, you can conveniently switch between different modes. And I would like to conclude my presentation for project 2. Thank you.